The noise function seems to be a little bit hard to understand. One viewer has been saying that it's not easy to see why the noise function can have 3 parameters. Sometimes we have used it with 1 parameter, or we have used it with 2. I'm going to try to explain this on a different way today. I'm going to use something I call the candy space. Candy space. I just made this up. And our candy space is going to be a box. And inside this box, there's lots of candies of different colors. I'm going to draw here some candies. Okay, there we have some different colors. And there's something very special about this candy space, which is unique. This wouldn't happen in real life, but the candies are usually or are always similar in color to the candies right next to them. So if we have here a red candy, the candy right next to it would be probably orange, and the next one would be yellow. You will not find a red candy right next to a blue candy. Even in my drawing here, it's totally random. But in this candy space, there is this special peculiarity. And we are going to use our noise function to get the color of the candies. So imagine I want to know which color is this candy right here. I'm gonna have to tell noise where's the position of this candy. So if you for a moment imagine this rectangle here in front is our computer display, we have been working already with X and Y axis. So this would be our 0,0 point. This is our X axis. And down in this direction is our Y axis. So we know how to locate a candy like this. We just have to know where it is on the X axis and where it is on the Y axis. So we know these distances. Maybe this could be 60,20, for example. This is how we locate things on our front surface. But what happens then if they are somewhere behind in this space? We're going to have another axis we're going to start using soon. This is the Z axis. And this indicates the depth, how deep, like behind or in front of our display, this position is. So that's why we need 3 numbers: X value, the Y value, and the Z value. But we've seen that we can use the noise function just with 1 parameter here. What's actually happening, processing then thinks that the Y and the Z values are actually 0. When we just enter one parameter, the others, or when we enter 2 parameters, the last parameter then is 0. Actually, internally, processing always works with these 3 parameters. The ones we don't enter are 0. And I can show this happening here just using a print ln. I'm gonna print some noise, a noise value of 3. And I'm gonna print the value of 3,0 and 3,0,0. And if I run this program, you can see that you get this exact same value for all 3 cases. So when I enter 3, actually processing is seeing 3,0,0. These 3 things are the same. So when I work just with 1 parameter here, I'm working with the X. Actually, what I'm doing is picking up the colors of the candies on this axis. The Y is 0, so I'm not moving in the down direction. And that Z is also 0. So we're just choosing the colors down on this line. We have mentioned also that it's good to choose values for our X or also for Y and Z that don't change too much between different calls to the noise function. So we saw that if I type here 3, 3,01 and 3,02, the number we get is quite similar. This is happening because we are picking up here candies which are very close to each other. And we said that in this candy space, candies which are very close to each other share color or are quite similar in color. If we would choose very distant candies, we might get totally different colors, like red and then green and then orange. In this case, noise wouldn't be very different to the random function. And we can see this already. If I type here 3, then 5, and then 7, then the numbers we get jump up and down and are very different from each other. So now let's visualize these candies here with a little program. I'm gonna use a x variable to locate our candies in the screen, and I will use a while loop while x is less than the width of the screen, then increment x by 40, for example. So this is how separated these candies will be on the screen. And I'm gonna draw then an ellipse and where, so in position x, 100, and the size will be 2020. So for now they don't have any color, they are just white dots. And then I'm gonna use here a fill color, fill, and if we are using now the hue, saturation and brightness mode, the first value here is the hue. That's the tone of our color. And I'm gonna use, if I use a random, let me use first just random tone and maximum saturation, maximum brightness. So you can see now the candies are totally random. These are not coming from our candy space. But if I now use 255 times noise and I enter here x, then we're getting some different candies. X is changing very fast. It's jumping 50 units at a time, so they are very separated. Let me create a variable here to make it a bit simpler. So I will store inside the color, so I don't have all these parentheses inside parentheses. So here you can see I'm just choosing fill with this color. And up here, I'm gonna define what color is, what this co is. I can print ln this x, so you can see it below. You can see then how it's jumping in big steps of 40, 280, 320, 360. If I divide this value by 500, for example, then now you can see the colors are very similar and the steps are quite small, 0.56, 0.64. Every time I run the program, processing will fill this box with a set of different candies. It doesn't change during the execution of the program, but every time I start the program, they are different. So you can see that now when I divide by 500, the distance between these candies is very small. So I'm picking up candies which don't change much in color. Now let's see in the next episode what happens when we use here 2 values instead of 1. Now we're just using an x value, but we will use 2 and we see how it makes a difference.